In this video, I will be proving the compound angle rule. For a trigonometric function such as sine of x or cos of x, they have a rule for what to do when you have to take the sum of two numbers. For sine of x and cos of x each, the rules are sine of alpha plus beta equals sine of alpha cos of beta plus cos of alpha sine of beta, while cos of alpha plus beta equals cos of alpha cos of beta minus sine of alpha sine of beta. In this video, we're going to prove those two identities. Sine and cos of x are defined geometrically, so it makes sense that our proof of the compound angle rules are geometric. First, we will construct a triangle ABC. We will define this triangle to be a right angle on C, so angle ACB is right angled. We will call the angle BAC alpha. We will also consider AB to be 1 unit long. Cos of alpha is AC over AB. But because AB is equal to 1, cos of alpha is just equal to AC. Similarly, sine of alpha is BC over AB. Because AB again equals 1, sine of alpha is BC. Next, we construct a point D such that ADC is right angled. We will call angle CAD beta. Cos of beta is AD over AC, which is AD over cos of alpha. Moving cos of alpha to the other side, we get cos alpha cos beta equals AD. Similarly, sine of beta is CD over AC. AC again equals cos of alpha, which means that cos of alpha sine of beta equals CD. Next, we extend the line CD to the point E, such that the angle BEC is right angled. However, we don't know the value of the angle BCE. The sum of ACD plus ACB plus BCE is half a revolution, but summing up the angles in a triangle also adds up to half a revolution. Because both end up equaling half a revolution, we can equate the two, and cancelling some terms out, we end up getting BCE equals beta. Now using this triangle, we can calculate sine of beta equals BE divided by BC. BC is sine of alpha, so we end up getting sine of alpha sine of beta equals BE. Similarly, cos of beta is CE divided by BC. BC is sine of alpha, so therefore CE is sine of alpha cos of beta. You may have noticed BE and AD are parallel, as DE intersects both of them at right angles. This means that there exists a point F on line AD, such that BFDE is a rectangle. The distance BF is the same as the distance ED, which is the sum of the distances CE and CD. Adding them up, we get sine of alpha cos beta plus cos of alpha sine of beta. Similarly, the distance DF is the same as BE, which is sine of alpha sine of beta. Finally, the distance AF is just AD minus DF, which means that it is cos of alpha cos of beta minus sine of alpha sine of beta. Finally, it is clear that the angle BAF is alpha plus beta. Therefore, we can take the sine of alpha plus beta to get sine of alpha cos of beta plus cos of alpha sine of beta. We can also take the cos of alpha plus beta to get cos of alpha cos of beta minus sine of alpha sine of beta. Therefore, we have just proved the compound angle rule for sine of x and cos of x.